So you've now found out how to find the trigonometric ratios of each and every triangle. Now what we're going to do today is find the unknown side, okay? But we're still going to use our knowledge of SOHCAHTOA, our mnemonic, for sine, cosine, and tangent ratio. So I'm just going to write that here. And we're going to use this to help us identify which one to use for each triangle. So for the first example, find the failure of the pronomeral in each triangle corrected one decimal place. We've got our side, which is our hypotenuse, opposite the right angle, and that's 200 meters. And the side which is adjacent or next to two of the angles, so the 90-degree angle and the 30-degree angle, that is our adjacent side. So by looking at SOHCAHTOA, A and H is in the mnemonic car, and that represents cosine. So we're going to use cosine of 33 equal to adjacent, which is n, over hypotenuse, which is 200. We then have to multiply that 200 over because we need to find n by itself. So we're going to do the opposite of 200 in this case to both sides. And that will cancel this out, leaving us 200 cosine 33, which we can type in our calculators. And if I swap those results around, so the n being on the left and then this result being on the right, n would equal to 167.73 ... So that would round to 167.7 meters. All right. Question D. Let's have a look at this again. Which rule do we use? We've got a side that's opposite the angle, which we call our opposite side. We've got an edge here which is right next to the angle here and also next to the 90-degree angle. So that's called our adjacent side. So using a mnemonic, we're going to use the tan ratio because O and A belongs to that, and T stands for tan. So tan of the angle here, which is tan 67 degrees and 36 minutes, is equal to R over 0.9. We're going to multiply both sides by 0.9 just so that we can get rid of that 0.9 on the right side since they're the opposite operations. We then cancel 0.9 like that, so that R in this case is equal to all of this. And to type in the degrees and minutes into the calculator, you use this button, degrees, minutes, seconds button, which is found on your calculator. Okay, it's between the minus sign and the hype button, okay, the HYP button. So if we type that in, 0.9, tan 67 degrees and 36 minutes, okay, that would give us 2.18, ... And because we're rounding to, again, one decimal place, as I said before, we are going to round that to 2.2 meters. Okay? Let's move on. Question 2. Find each length or distance correct to one decimal place. So for part A, it's asking how high the stairs go up the wall. So we're now looking at this length here. If we call this maybe x that we need to find, the relationship between the sides and the angle given is that this is opposite the angle given, so we'll call that O, and then this longer edge here is our hypotenuse. So by using SOHCAHTOA, okay, which I'll write down again, you know that O and H belong to the first bit, so that represents sine ratio. So sine of 40 is equal to x over 355. So if I now multiply both sides by 355, which is the opposite of dividing by 55, okay, we get that. So dividing by 355 and multiplying by 355 cancel, so that x is equal to 355 sine 40, which on my calculator gives us 228.18. ... There's more numbers after that. And when we round this to one decimal place, like it's what it says on the question, it will be 228.2 centimeters. Moving on. Question B. Let's find the distance between the boat and the start. So that means we're finding out this distance here, which again we'll call x. So that length there, that is right between the 90-degree angle and the 45 degrees, okay, is our adjacent edge to both the angles. So we'll call that A. And our hypotenuse is right opposite the 90-degree angle, which we'll call H, like that. So then what we do is we use, out of the mnemonic, we use the middle bit, which is CA. That stands for cosine ratio. So cosine of 45 is equal to the adjacent edge, which is x, over 200. We then get rid of that 200 by making x by itself, and we multiply that by 200 on both sides. This will enable you to cancel that division by 200 and multiplication by 200. So that x equals to 200 cosine 45. That's 141.42 ... So that this rounds to 141.4 meters. Okay. Moving on to C. The distance from the observer to the base of the building. So that means we're finding out this length, okay? Because here's the observer. The base of the building refers to the bottom of the building, which is there. So this is the missing edge. We'll call that x. This edge here is opposite our angle 77 degrees, so we'll call that opposite. And this edge here, which is 155, is right beside the angle 77 and the 90-degree angle, so we call that the adjacent edge. So just by using SOHCAHTOA once more, we're using the third part of the mnemonic, which is the tan ratio. So tan of 77 degrees is equal to the opposite side, which is x, over 155. We multiply both sides by 155, like so. So that will give us 155 tan 77 equals to x, basically, if you cancel that out. So 155 tan 77 is going to give us 671.37, and there's more numbers after that. So let's round that to one decimal place. That would be 671.4 meters. Okay, so that's about 671.4 meters in length, which is pretty far. Question D. The height of the boat's mast. Okay. So this mast is attached to the boat, and so you want to find out how high this mast is, but you're given this length. That's the hypotenuse. So I'll call that h first. The height of the mast is opposite this angle, so we'll call that O. So using SOHCAHTOA, we're basically forced to use the sine ratio. So sine of 47 is equal to, we'll call this x here, over 1,440. Now we multiply 1,440 over, so this cancels. So 1,440 times sine 47 is going to give us 1,053.14, and that rounds to around 1,053.1 centimeters. I should say also that whenever you're finding out something that's to do with the opposite side or the adjacent side, it must be less than the hypotenuse. So make sure that this number is less than that. That's how you check whether it is towards correct or towards not being correct. Okay? All right, let's have a go at question 3. Find the value of each pronumeral correct to one decimal place. So in this case, I've got my opposite edge here, my hypotenuse here. Okay? So very similar to before, we're just going to use our sine ratio, because when we look at SOHCAHTOA, the first one is where O and H is. So we use sine 20 equals to opposite, which is 35, over x. Okay. Now, remember what we used to do. Okay, we've done this last year as well in year 9, and we've had to basically swap. Okay, we've had to basically swap the x and the sine 20 around when x is on the denominator. So we're going to swap these around. Okay, we're allowed to do that only when the x is on the denominator. So if we swap those around, x would equal to 35 over sine 20. So 35 divided by sine 20 would then equal to 102.33. I keep going. So let's round this off to one decimal place. This will be 102.3 meters. Now let's have a look at question D. Opposite this angle here is 14.85, so we call that opposite. Our longest edge is opposite the right angle, which we call hypotenuse. So then we're going to use the sine ratio once again, because the sine ratio involves opposite and hypotenuse. So sine of the angle, 43 degrees and 43 minutes, is equal to the opposite edge, which is 14.85 over r. Now once again, our unknown letter is at the very bottom, okay, on the denominator. So we can swap this with the other term on the other side so that we can get that letter by itself. So r is 14.85 all over sine of 43 degrees, 43 minutes. So if I do that on the calculator once more, I get r equals to 21.48, with more numbers after that, and it rounds to 21.5 meters. Okay? So these questions are good examples of where you have to move the denominator, which is unknown, okay, to the other side by just swapping it. If it's not that way, say for example, you have sine 20 equals x over 35, then you keep that x there, but you multiply both sides by that 35 on the bottom to get rid of it. Okay? So those are the two ways you can do these types of questions, when x is on the numerator or x is on the denominator. And that's it.